Hi all, a very good evening. So this is our first class in this series. Hope you guys will enjoy the show. And let's get started. The topic of today discussion is unit and dimension. And Hold on. Yeah. So the topic is unit and dimension. Unit and dimension. And So this is our first class in this series. So for that, to understand unit, we need to first understand about quantity, that is physical quantity. Physical quantity. Uh, See, uh, all those quantity which can be measured is called physical quantity. Uh, how we can define it? All those quantity, all those quantities which can be measured, which can be measured called physical quantity. Called physical quantity. So for that example, we can consider, for example, we can say velocity, momentum, force, etc. So we can say anything which can be measured through any instrument is called physical quantity. And Now we can further classify. Now we can classify physical quantity. Physical quantity into two parts. First one is uh, fundamental quantity. Fundamental quantity. And second one is derived quantity. Derived quantity. Okay. So we further classify physical quantity into two parts, that is fundamental quantity and derived quantity. So we already studied about this fundamental quantity in class 9th. You might have ideas about what is fundamental quantity and how many are fundamental quantities. So there are seven fundamental quantities. There are seven fundamental quantities. Mental quantities. So if someone asks you what is fundamental quantity, so how you will define that? Um, See, if we have to define fundamental quantity, we can define it as like any quantity which are not dependent on any other quantity. A quantity, a physical quantity which are a physical quantities which are not dependent on any other quantity, right? On any other quantity. So see, fundamental quantities are those quantities which are not dependent on any other quantity. It is independent to any other quantity. So there are seven fundamental quantities. These are: first, length; second one is mass; third one is time; then temperature; then current; then luminous intensity, luminous intensity, intensity, and last one is amount of substance, amount of substance. So these seven are fundamental quantities. In it is written as length L, it is mass M, this is time T, this is temperature, and for current we can write I. For temperature we can write it as K. For luminous intensity, luminous intensity is generally represented as CD, candela; amount of substance, mole. So these seven are our fundamental quantities. So let me first give you some examples of. See, so these seven are fundamental quantities. Now we need to define derived quantity. We have understood that what is fundamental quantity. Now let's understand derived quantity. Derived quantity. So see, by its name you can understand that derived means which can be extracted from any other things. So derived quantity is nothing but those physical quantity which are derived from fundamental quantities. So we can define it as a physical quantity a physical quantity which are derived, a physical quantity which is derived from fundamental quantity. Fundamental quantity. That is called derived quantity. So for instance, if we have to take some example of derived quantity, so you can say a speed, you can say force, you can say density, etc. There are many derived quantities. So how we can say a speed is derived quantity? So let's understand that we know that a speed is distance upon time. The distance is nothing but length L and time is T. So these two are derived quantity. Sorry, these two are fundamental quantity, length and time. So now we have understood that speed is nothing but the ratio of two fundamental quantity. So that is why we say derived quantity is nothing but those quantity which are derived from fundamental quantity. So that is why speed is a derived quantity, right? Now let's understand about units. Units. See, if we have to write, if someone tells me write 5 speed, so how we will write it? 5 meter per second. If someone tells me write force, a force of 8 newton, so how we will write it? 8 newton, 8 n. So by unit you can say that this can be a speed or this can be velocity. By this newton you can say this is force. So someone asks you why do we need units? So we can say unit is something which is required to differentiate physical quantity. If we do not have units, then how you will classify, how will you differentiate whether it is speed, whether it is force, whether it is torque, whether it is momentum, whether it is velocity? For that reason we need to have units. And you know what, in ancient times there are different kinds of units. Each country, each particular region has its own kinds of unit, like someone measure through hand or by their, you know. So this is not there is no uniformity in units. So for that reason there was a conference held in 1971 in France, where scientists have decided that we should adopt a a system which is valid all over the world, right? That system is called SI system. SI system. You generally in this study about SI unit of force is Newton, SI unit of pressure is Pascal something, right? SI unit of length is meter, SI unit of uh, momentum is meter, SI unit of acceleration is meter per second square, these things, right? So in 1971, scientists have adopted this SI system. This is valid all over the world. Whole world adopted this SI system in 1971. Since then, we have been following this SI system. Apart from this, there are other systems like a CGS system, MKS system, and FPS system. So mainly we have to study these four kinds of system of units, right? So now let's start from first one, SI system. So here I am writing quantity, and here SI unit. So let's start from our fundamental quantity. That is, first one is length. So SI unit of length is nothing but meter, m. Then we have mass. So SI unit of mass is kg. Then we have time. So SI system of time is second, s. Then we have temperature. And SI system of temperature is Kelvin, K. Then we have you can say current. SI system of current is ampere, A. Then we have amount of substance, and SI unit of it is mole. And last one is luminous intensity. And SI system or SI unit of it is candela, CD. So these seven are fundamental quantity and their SI unit. Now let's understand SI unit of some derived quantity. So let's start from our acceleration. What is acceleration? Acceleration is nothing but rate of change of velocity. So change in velocity upon time. We generally represent acceleration by small a equal to change in velocity, that is delta v upon time, t. So we know that velocity is what? Velocity equal to distance upon time, right? So distance is what? Length upon time. So length is what? SI unit of length is meter and SI unit of time is second. So we can say that SI unit of velocity is meter per second, right? Now we have understood that SI unit of velocity is meter per second. So then we can write it at delta v. SI unit of velocity is meter per second upon time. So SI unit of time is second. So then SI unit of acceleration will be meter per second square, right? So in this way, we can derive the SI unit of other derived quantities. You just need to have, formula for that quantity. So like if you have to, you know, if you have to find the SI unit or unit of any physical quantity or derived quantities, you need to have formula. Like if you have to calculate SI unit of pressure, SI unit of pressure. So pressure is what? Force per unit area, right? Force per unit area. So now first we need to understand that what is SI unit of force. So in earlier classes, you have studied that force equal to mass into acceleration, F equal to ma, right? So SI unit of mass is what? Kg. And we have just calculated the SI unit of acceleration, right? That is meter per second square. So it becomes kg meter per second square. Now this is what we call Newton. In the honor of Newton, we have accepted the SI unit of force is Newton. So if someone asks you what is Newton, Newton is nothing but kg meter per second square, kg meter per second square, right? Now from here you can say that force is kg meter per second square upon area. Area is what? Area is what? How you will calculate area? You know area equal to length into breadth generally, right? So we can say it is meter square, right? So from here, if you have to calculate, you can write it as kg meter upon meter square second square, right? Let me first erase this here. So from here you can now you can write it as kg. Now this meter and this meter will be cancel out. So this becomes kg meter per second square, right? Kg per meter per second square. So this is what we call it Pascal. In the honor of Pascal, we have accepted the SI unit of pressure is Pascal. And if someone asks you what is Pascal, so you can say that Pascal is nothing but kg per meter second square, right? So in this way, we can calculate unit of any derived quantity, right? Hope you get understand that. Okay, let me give you some more example. Hmm. Okay, so if you have to calculate, I'm just writing the formula and I'm giving you 1 minute of time, and in that time you have to calculate unit of that system. You know that tension equal to not tension, surface tension. Surface tension. Surface tension is what? Force upon length. So this is the formula for surface tension. Now you have to calculate unit of surface tension. So you can pause the video and try to solve this. So see, how can we calculate the unit of this system? Surface tension. We can, let's write it as T. Okay. In short, T equal to force F upon length A. Now, force is what? Newton. And Newton is what? Kg meter per second square, right? And area is what? Length square. So length square means meter square. M square. Small m square, right? So we can write it as kg meter per second square upon m square. Now this becomes kg meter upon meter square second square. So you can write it as kg. This meter and this meter will cancel out. So this becomes meter per second square. So kg per meter second square will be the unit of SI unit of surface tension, right? So in this way you can calculate the SI unit of any derived quantity. Now so this is all about SI system, and I have given you some examples how you will calculate, how will you find out that SI system of any derived quantity or fundamental quantity, right? Now let's understand, if so if we write 5 meter, what does it mean? 5 meter, it means it is 5 times of 5 generally tells about magnitude, and meter is unit. So it tells about 5 times of meter. If we write 5 meter, it means 5 times of meter. 5 times of meter. So this is the general interpretation of if we write any physical quantity with the unit, so what does it interpret, right? It interpret that how many times of that unit. So like if we write 8 ampere, 8A, it means 8 times of ampere, 8 times of ampere. Hope you understood that, right? So this is the general interpretation of our unit. Now let's move to the another system of unit, that is CGS system. CGS system. What is CGS system? So CGS system is nothing but centimeter, gram, second system. In this system, unit of length is centimeter, unit of mass is gram, and unit of time is second. This is all about CGS system, right? In further classes or in later part of this lecture, we will change one unit to another unit. We will learn how to change SI unit to CGS unit, CGS unit to SI unit, or CGS unit to FES unit, right? So this is all about CGS system. Now let's understand about MKS system. MKS system. MKS system. What is MKS system? Meter, kilogram, meter, kilogram, second system. Here, unit of length is meter, unit of mass is kilogram, and unit of time is second. This is MKS system. And then we have FPS system. FPS system. Foot pound second system. Foot pound second system. Here unit of length is foot, unit of mass is pound, and unit of time is second. So this is our FPS system, right? Now we have understood that there are four types of system of units, that is SI unit, foot pound second units, meter kilogram second unit, or CGS unit, right? Now the question arises, how we change from one system of unit to another system of unit, right? So we will now learn about conversion from one unit to another unit, right? So let's start. From SI system to CGS system. Okay, so let me take some examples. So see, we have to understand how we will change SI system to CGS system, right? So there is formula N1U1 equal to N2U2. We will use this formula for calculating to change one system of unit to another system of unit, right? But see, this thing we will discuss in next class. This is all for today. Okay, hope you find it helpful. Thanks a lot for watching this